So in the class on Monday, we were speaking about compression techniques to give some idea of how to improve the efficiency of inverted indexes. So we spoke about these different numeric compression techniques. Okay, so in terms of dealing with documents at very large scale, as is the case in Google, but also in the case of other websites that have to deal with indexing, say, hundreds of millions of documents, it can be beneficial for scalability and for efficiency to use multiple machines, which is a recurring theme in the course. So when we deal with lots of data, we'd like to use multiple machines. So the question is, how might we distribute an inverted index over multiple machines? Any ideas? So we have our inverted index here, which has the term list, which lists all of the normalized words or terms. And we have the posting list, which in this case, we assume it's a record level index, right? It just assigns the IDs of the documents containing those words. So any ideas on some possible alternatives for distributing the index over multiple machines? Using hash for every word. Okay, so we can hash by term, right? So we can split by word or by term, right? So in this case, all of the information for and, for example, will be on one machine. All of the information for cat will be on another machine, and so forth. So we might end up with a distribution like this. Okay, so we have dog on one machine, and vet, and so forth. The key part is that we have all of the full posting list, all of the documents associated with each word on one machine. Okay, so what would the advantages of this be? Any ideas? Or disadvantages? Is it good? Is it bad? Does it make sense to do it like this? Any ideas? Yeah. So the main benefit, I don't know if you heard that noise, I don't know what it is. The main benefit is that if you get a query for a word like dog, you can figure out which machine, all the documents for dog, where those documents are, and you can go directly to that machine and get all of the results, right? Likewise, if you get for maybe dog or cat, you'll know to go to machine 1 for dog and cat for, or machine 4 for cat. So this is quite useful. This can make it more efficient. Is there perhaps a disadvantage? So the disadvantage is if you have a Boolean combination with and, where you want to see, find all the documents that contain, for example, dog and cat. Now what you'll need to do is intersect across machines the different, the posting lists. So somehow you'll need to either ship the posting list from machine 4 for cat to machine 1 to intersect it here, or from 1 to 4, or maybe shift them to a master or something like that will do the intersection. So it requires intersecting across machines, the posting list across machines. So there's some advantages and some disadvantages. Okay, so the advantages are that we know where for each word, which machine will store the full posting list. But okay, another complication would be, for example, a word like the or a word like and. So the should constitute 7% of the non-unique words in English. It's the most common word. So this machine here will have to store at least 7% of the data regarding the posting list. In other words, this posting list could be very long. And this could be even worse if we have positional information, if we're storing positional information in the inverted index. So another issue would be that it would be difficult to do and or stricter phrase search, where you have the words sequentially within each document, as it will require doing intersections across machines. Another slight kind of practical issue is that it might be difficult to store statistics for a document. For example, how many words are in a given document, because no machine is assigned to a particular document. They're assigned by word. So, okay, we could resolve that. That's not maybe a major issue. So load balancing is a bit of a problem, and doing and or phrase search will be a bit of a problem. So what would an alternative method be? I should mention as well, another practical disadvantage is that it's going to be slightly more complicated to do the indexing, because when we get a document, we'll have to store data in different machines. Okay, so we'll have to split up the words and somehow write to all these different machines. So the other option is rather to split by document. So in this case, we can just simply send a document to one of these machines, right? And that machine will then index the full content for that document. So what would be some advantages and disadvantages of this scheme? So the key disadvantage is that we're going to have to be able to, for any keyword search, it doesn't matter what it is, we're going to have to ask every machine. Okay. So we're going to have to send our query to every machine, because we don't know which documents might contain those keywords. Okay. So we need to flood the query. We need to send it to all of the machines. Now, there is a big advantage, which is that we can do phrase and search within individual machines. There's no intersections across machines. Of course, we'll have to take the union of all the results later, but we could imagine that the documents, we will only have to take the union of the valid documents that satisfy the criteria for the search. So this means that, okay, possible disadvantages, we'll always have to run the query over all machines and take the union of the results over all machines. Okay. So what are the benefits? The benefits are that we don't need to intersect posting lists across machines, which is nice. And we don't need, we have better load balancing, in the sense that, you know, unless we have a very, very, very large document, we shouldn't really have much of an issue with load balancing, because we're not partitioning by word. So yeah, the other disadvantage is, of course, at the inverted index. If we look at the number of terms, excuse me, every inverted index would have to, on each machine would now need to store the full list of terms, or almost the full list of terms, right? So we would imagine it would have to cover most of the terms that have been seen in the inverted index, whereas before they only needed to cover about 1/4 of the terms that are encountered in the document. Okay. Again, this is usually not such a big issue, because the number of unique words in general in a language are not going to be that high. Okay, so in general, in fact, I mean, there's no clear winner here, but the most common type of distribution, particularly due to the load balancing issue and the need to intersect posting lists, these are pretty big disadvantages. The most common type of distribution is this distribution, splitting by document. So it has also the benefit of being easier to index the data. When you just get a document, you just send it to one machine and get it to index in its local inverted index. But it has this disadvantage that you need to query all machines and union the results for any keyword search in terms of the partitioning. Okay, so in reality, you know, there might be, for very large inverted indexes, like at the level of Google, there might be some more complex distribution going on, maybe a mix of word level, or split by word, split by document, and also considering replication. So, but okay, these are the two kind of core ways we could distribute an inverted index. So, any question or doubt? Okay. So in terms of actually building an inverted index in the lab, where you're not going to code an inverted index from scratch, because there already exists some very good implementations. So one of the most widely used implementations of inverted indexes is called Lucene, again, an Apache project. So they've implemented an inverted index in Java. It's an open source project, as the Apache name signifies, and it's built for just one machine. Okay. So in general, Apache Lucene is a very good project. It's been around a long time. It's highly optimized. It's gone through several versions. It's widely used, and it works very well. In general, it's surprising how efficient it can be, or how quickly it can index documents and so forth. So it's a very good solution. It's also relates to the other tools we've seen in that Doug Cutting, this guy here, whose elephant's called Hadoop, was involved in Lucene originally, Notch, this crawler, with Mike Caffarella, who's below here. And both of these guys were also involved in Hadoop. So they're kind of key figures in the Apache scene, but also in terms of some of the most important big data projects that have been released. Okay. So on top of Lucene, Lucene is a kind of a lower level inverted index, and it allows you in Java to index documents, search documents, and it really provides all the motor, all the implementation in terms of data structures, queries, and so forth that you need for an inverted index. But there are two higher level tools that use Lucene as an engine and then provide higher level interfaces. The first of this is Apache Solr, and the second is Elasticsearch. So Solr started out its life as this idea of having kind of higher level interfaces where you could sort of have an API rather than having to programmatically index documents. You could use a higher level interface for indexing documents. Later, it added distribution by document. So later, it added this facility to be able to distribute Lucene indexes across multiple machines, but it's kind of a later feature. It wasn't designed specifically for that. Elasticsearch came along later. So Apache Solr is open source, open community, and so forth. Elasticsearch came along later, and it began life as a distributed index. Its main focus was to enable scalability across multiple machines. And it also offers higher level interfaces based on kind of JSON type requests. So this way you don't need to configure necessarily programmatically your index. You can use an API for that. So in general, the more commonly used would be Elasticsearch. It's commonly used as well in the context of other tools which allow for such as Kibana, which offer nice visualizations for doing log analysis. Elasticsearch itself is open source, but there is a company behind it. So there's this company called Elastic, I think, which is sort of has some commercial is a company that's maintaining Elasticsearch and other related tools. So a common use case for Elasticsearch is to be able to search, index, manage logs in large companies, logs from applications, for example. So Elasticsearch is the most commonly used, and it's the one we'll have a look at in the lab, the one we'll use in the lab. So maybe just a brief word of warning, and we're starting into Elasticsearch, and this will apply generally to NoSQL systems that we'll see. There have been cases of, I don't want to say Elasticsearch is particularly bad in this sense, but it is important to mention that there have been breaches that have arguably been related to Elasticsearch vulnerabilities, let's say. So the Elasticsearch is maybe not as mature in terms of applications as what you would expect in relational databases. And there's been some relatively serious breaches involving, 14 million customer records, for example. Now, whether or not that was really based on a problem with Elasticsearch or just some naive use of the database by the company, that's completely open. But it's a word of warning that maybe just take care if you're thinking about using Elasticsearch especially for something like a web application or some instance of Elasticsearch with an open API, to be a little bit wary and to do your own investigation about these sorts of issues to see whether or not it might be a problem. It's in general good for text documents, but it can also offer some structured queries as well, like JSON-like stuff. So it's kind of similar in a way to MongoDB, which we'll talk about later, but more focused on inverted indexes and text search. So yeah, with that word of warning, we're going to be using Elasticsearch. So any questions or doubts? Okay, so just to mention, in the lab, you'll be indexing data from Wikipedia in Spanish. We'll give you most of the code and we'll ask you to fill in some gaps that we've left. So you'll need to expand the code to have a complete solution. You can use the API pretty much for everything, and you can have clients for the API that, you know, index documents directly against the API. But we're going to do this programmatically, mainly because you in any case need a client. So we're going to use a Java client. And for indexing, sending a request for every document is maybe not ideal, because all of these requests, sending millions of requests for millions of documents, can create a high overhead. So we'll be using specifically a bulk loader that's available in Java to make things more efficient and more reliable in terms of indexing. So yep, so that's the lab. You will take data abstracts, paragraphs of Wikipedia articles, of all of Wikipedia, and you'll be indexing those in Elasticsearch, and then you will be implementing the search functions. So we have an enunciado, will give you all the instructions for that, and you also have a partial solution that you just need to complete. So any questions or doubts?
No, profe.
Okay. In that case, so you want to get started on the lab, right? So let's move to Discord.
I have a question.
Sure, go. Yeah.
There was an alternative to Elasticsearch.
Solr.
Solr. And does Solr have any breaches? Or any known?
Solr is not so popular as Elasticsearch. So I think Solr is really kind of, I would say, from the same kind of community as Lucene, in the sense that it's sort of, it's an Apache project, right? So it's more of an open source type community, but they have a very nice engine. I mean, the engine is the same. They offer similar features. The reason why Elasticsearch is so commonly used in practice is that Elasticsearch is combined with other tools that offer visualization, like Kibana, and they have a log processing tool as well, which is called log something. And there's this framework called ELK, E-L-K. Yeah. I don't remember what the logan, no, I don't remember what the L stands for, but it's log something. So this is a very common framework for processing logs. So Elasticsearch is Logstash. I think that sounds familiar, yeah. So it's a very commonly used framework, and in some sense it wouldn't be fair to compare them in terms of breaches, because Elasticsearch has seen more use. It's more popular in practice, and that's the main reason why we use it in the lab. It's just a popularity argument. Has there been breaches from Solr? Possibly, probably, I'm not sure. But I think in general, it would apply, the message applies more generally than any one specific system, particularly when working with these sorts of NoSQL systems. Elasticsearch is one of those. We'll speak more about NoSQL soon in 2 classes time, in 2 weeks time. But the general warning would be to do your research and figure out if there are security issues, if it's okay, you know, have the security issues been resolved or not. Solr, I wouldn't expect to have had so many breaches, just because the way it's not really used in the same way, let's say, or to the same extent as Elasticsearch.
Perfect. Thank you.
Okay. Yeah, so any other questions or doubts? Okay, so if not, we can move to the Discord. If you've got any doubts, we can answer there as well, of course. So see you in the Discord.